So this is essentially the second part of the multiple inheritance lecture. This in this lecture we are going to talk about the multiple inheritance aspects in C++. So one way to also treat this as the is to treat it as the third part of the classes in C++ lecture. It doesn't matter, right? The overall idea is that we are going to see how multiple inheritance and issues associated with multiple inheritance are resolved in C++. So the first thing you should know is that C++ does support multiple inheritance. There are certain languages, for example, which do not support multiple inheritance, but C++ does. So in C++, you can therefore have more than one base classes for a particular class. The way to declare multiple base classes is very similar to how you do it for the single base class. You basically separate these classes by commas. Of course, you'll also need that access specifier in order to tell where the elements from this class are going to land in the derived class. It is also fine if two or more base classes have members of the same name. Now as such it is not a problem. You can access them separately. Okay, so as long as the access to them is not ambiguous, there is no problem. You can inherit two classes which are going to have even the same name members, but as I said, there has to be unambiguity whenever you try to access it. And in addition, there is a provision to protect multiple copies of the same member as well. For example, whenever we are having the case of diamond shaped inheritance, in such a case it's basically a wastage to have two copies of exactly the same member. So there is a provision to make only a single copy of such members. The issue might be that the constructors become slightly more complicated. You know that constructors in C++ are already very complicated, especially when you have the case of inheritance. You have to basically pass on some parameters to the base class. Now here, when you have multiple inheritance, you have to pass on the parameters to multiple classes constructors. And if it is the case of diamond shaped inheritance, and you have to resolve the problem using some mechanism, then even more calls are to be made from the header of the constructor. So just to give you an example, we've been following these toy examples all this while. So last week we saw the example of battery operated toys, right? So basically I said battery operated toy is a kind of specialization of the class toy. So this two doesn't really matter much. I mean, it's essentially the same battery operated toy only. There are some changes, so I've just called it battery operated toy 2. But logically it's exactly the same thing that we've seen in the previous week. So now I'm going to say that let us talk about these toys, right? These aeroplane toys, which even fly to some height. I'm not sure exactly if I know the correct way to call them, but here I'm just calling them as plain toys. They are probably not toys. I mean, they are very complicated toys, to be honest. They are more like a drone in some ways. But yeah, as of now I'm just calling them as plain toys. So basically I say that there's another class of toys called flying toys, and these are again inheriting directly from the toy class. So I say that a plain toy is simultaneously a flying toy as well as a battery operated toy. So there are two different types of properties that this class plain toy is going to inherit. One set of properties from the flying toy class and another set of properties from the battery operated toy 2 class. And the syntax is, as you can see, very similar to single inheritance. Instead of just having one class here, you can put a comma and put as many classes as you want here. So similar, so you can see that it is public flying toy and public battery operated toy 2. So the meaning of public is exactly the same as it was in case of single inheritance. So now whenever we are having this multiple inheritance, one way to look at it is single level multiple inheritance, right? So this is what we just saw, that flying toy and battery operated toy. As if you for a moment you forget that both these are deriving from toy 2, just by seeing that line you might say this is a single level multiple inheritance where there are two classes. And then there is a child class which is deriving from it. So if just to use some terminology, assume that you have a class called child, Here the child is of course plain toy, and then it is inheriting from two parent classes. Okay, we'll call them as parent 1 and parent 2. This 2 should be small. So then there may or may not be members which are common in parent 1 and parent 2. This is what we've been discussing all this while, that what will happen in such cases, that you have some members which are of the same name in both the parents or more than two parents. So in C++, it is allowed to have such kind of a scenario. So you can have a class child which is inheriting from two base classes, parent 1 and parent 2. It is also possible that parent 1 and parent 2 have some members which have the exact same name. Now, as long as these members are not accessed in the derived class, the compiler will not complain, right? If you simply don't access these members at all, there's no problem, right? Compiler doesn't raise any alarms. In fact, what will happen is that in such cases, it will create multiple copies of such variables, right? So there will be one for parent associated with parent 1, and there will be one associated with parent 2. So if you have the same variable in both classes, in child you will have two versions of this variable, right? One associated with this and one associated with this. Now if you want to access these members, okay, then you must do it in an unambiguous fashion, right? If there is any ambiguity, then compiler is going to raise an alarm, right? So for example, this method, I think we have seen this, the start playing method. So it is there in both flying toy as well as battery operated toy. So if you want to access this method, for example, with the help of an object of plain toy, then that is going to be a problem. Why? Because the compiler doesn't really know which of the two definitions are you really wanting to access, right? This one provided here or this one providing here. So in this case, it needs the by the way, this is not dot, this is the scope resolution operator here. Yeah, sorry, I'll change the slides before I upload it. So here it is scope resolution operator, and what compiler expects from you is that whenever you try to call either one of these member functions, you provide uh, an unambiguous identification for the definition that you are trying to execute. So that is why if you put the scope resolution operator here, then the compiler can figure it out, and that is the overall idea. Um, whenever you are actually going to access any member from your let us say the top, the grand grandparent, that is what we see in diamond class, in the diamond shape problem. Whenever you try to access something from the grandparent, this problem will become even more uh, you know uh, even more specific, because then you will always have at least some members, at least inherited members, which are going to have the same name. So the use of scope resolution operator is very important whenever you are trying to access any member from your parent classes. The idea is you must make it unambiguous. As long as they are unambiguous, there are no issues. The compiler will not raise an alarm. Or if you don't use any members at all from these classes, then also there is no issue. But if you are going to use it, you will have to use the scope resolution operator. The constructors in case of multiple inheritance are exactly the same as single inheritance, with the only exception that now instead of calling just one base class constructor, you are now calling two base class constructors. So this is an example that here I am taking all the arguments here in this derived class constructor, and then whichever operands are required to be passed on to the base classes, I just put the colon and then call the first constructor, then comma, call to the second constructor. Now this whole idea of parent and child was fine until you did not have a grandparent, right? So what I mean by a grandparent here is, let us say parent 1 and parent 2 are deriving from a grandparent. Okay, so there is a class which is a base to both these parent 1 and parent 2, and then you are going to inherit it in child, right? So child, so now I have that diamond problem, as you understand, right? There is one base class, there are two classes which are going to derive from that base class, and then these two derived classes become the base class for another class. It's just the diamond shaped problem that we have seen. So in C++, how do we deal with the diamond problem? So again, you are allowed to have diamond shaped inheritance, no issues, as long as you use the scope resolution operator properly. So so basically what will happen is all the elements from grandparent will travel to the parent 1 and parent 2 classes, and then from parent 1 and parent 2 they'll travel to child. So there will be two copies of these members in the child object, right? Now as you might understand that this is exactly the same member which is coming from grandparent, which will be duplicated in the child, right? So this might be inefficient and it might be illogical too, that it's exactly the same member which is having two copies. So C++ allows you to provide advanced information to the compiler that I am going to have something like a diamond shaped inheritance, so please make sure that there are no multiplicities for the members coming from grandparent. So in that case, C++ compiler makes sure that only a single copy of the elements coming from grandparent are maintained for the child class. Okay, so to do so, you must provide some information at the time of creating parent 1 and parent 2 itself. Keep this in mind, that this information has to be given when you are creating parent 1 and parent 2 itself. So what you really do is, at the time of inheriting grandparent, you make this inheritance as virtual. You can do that by simply putting the word virtual before grandparent, and this information is all that C++ compiler needs to know in order to know that later onwards parent 1 and parent 2 could be common base classes for some other class. Okay, so something like this. So this flying toy class and the battery operated toy 2 class, they both have this virtual keyword before public toy 2 and public toy 2. So this means that toy 2 is now being virtually inherited by these two classes, flying toy and battery operated toy, and you've already seen that these two classes were the ones that were being inherited by plain toy. So if you do so, if you inherit any classes virtually when you create a child, okay, the members from grandparent are only maintained once, right? So only one copy of the members coming from the grandparent are maintained in the child. Okay. Now again, the constructors have always been something that we have to look at, right? I mean, constructors, as I've already said, are slightly more complicated in C++. So if you use virtual inheritance, as we just discussed, you may have to do something more, right? Why? So this is the overall idea. The grandparents constructor if you are not inheriting virtually, then what would have happened? You would have only invoked these two constructors, flying toy and battery operated toy, and you know that the constructors are invoked in a fashion where the class which is at the top of the hierarchy, that class's constructor is called first, then the class which is a child of this class, that constructor is called, so on and so forth. So you move from top to bottom. The class which does not have any base class, that class's constructor gets called first, and then its derived class, then that for its derived class, so on and so forth, until you reach the last level of the hierarchy. So if you do not have virtual inheritance, what really happens is the constructor for toy 2 will be called twice. Why? Because you called the constructor to flying toy, and then implicitly the constructor from flying toy will also call the constructor to toy 2, and similarly when you call the constructor to battery operated toy 2, in a similar fashion, first the toy 2 constructor is called, and then the battery operated toy 2 constructor is called. Now here we really don't need that, right? Because we are only keeping a single copy of the variables from toy 2. So one way to do that is that the compiler calls the default constructor for toy 2, and then then the things are done, you don't need to do anything. But it is possible that in the grandparent class you do not have a default constructor at all. In such a case, the compiler will again raise an alarm. It will say, I really don't know how to create an instance of toy 2 first, and then only can I use that instance to create instances of flying toy and battery operated toy. So this is where you'll have to add one more call in your constructors header, you can already see how complicated this header has become. So here I not just flying toy and battery operated toy 2, I also need to call the toy2 class sys constructor, right? And all these parameters you have, something from here needs to be passed here as well. So you can already see it's becoming really messy, and this is why right at the beginning I said, if it is possible, avoid multiple inheritance. I personally do not like to use multiple inheritance, but still it is a language feature. So many a times when you're reading C++ code, you might look at something, you might see something like this, where a particular class is inheriting from multiple classes. So you need to know, at least you need to have a knowledge of how multiple inheritance works, how these constructors are called. Okay. And yeah, this is the complete example where I'm creating an object of plain toy, and then I'm just invoking some methods. So basically, as a part of your homework, you have to go and just analyze this output so that you understand the overall flow in which the constructor was called. Where you called a particular method, you can see that I'm not using any scope resolution operators here, right? Basically, start playing, I'm simply calling over the pt object directly. I don't need to have flying toy scope resolution operator start playing. Why? Because again, I mean, the idea is that you are doing virtual inheritance, and in case of virtual inheritance, you can only a single copy of the members are maintained, and now this is absolutely possible to do so. Okay, so thank you. Let's have a look at the homework. That is exactly as I have already told you. We will discuss this in the extra class today. So if I know it's already late, but if you have any queries, we'll take it up at the time of extra class. Thank you. Bye.